Alright guys, I'm going to go through 15 rearranging and solving quadratic equations. So this video might be quite a while, so it'll probably account for a day's work in itself. So hopefully you've done these 15 questions before I go through them, because that's how you're going to learn. So if you haven't done these questions before, then I recommend when I turn each page you pause and you give each question a go. They're going to be coming through in fours. You're going to be given the opportunity to pause the video, give each 4 questions a go, hit resume, and you're going to be able to see me complete the working. Okay, so solving quadratics. Okay, two big ideas. You need your quadratic equation to equal 0. So if it's in the form ax squared plus bx plus c, that needs to be equal to 0. Because once it's equal to 0, you can factorize, and you can just solve each factor for 0. Because if 2 things multiply to 0, then obviously one of those factors is equal to 0, or the other one is equal to 0. So then you can easily solve for those 2 numbers. So a quick example, x squared plus 4x minus 5 is 0. Factorize. So you've got x plus 5 and 1 is one factor, and x minus 1 is another factor, and they multiply to 0. So then solving the first factor, x is negative 5. Solving the second factor, x is 1. Alright, there's quite a few problems, so we need to be moving through this quite quickly. So, since there's a video, you can always just pause, go back a few seconds if you think you've missed something. So question 1, so you could pause now and give these 4 a go. Question 1, x squared is equal to x plus 30. So it's not in the form ax squared plus bx plus c equals 0. We need to get it into this form first. So we can subtract x and subtract 30. From both sides. Now it's equal to 0. Next thing, now that it's equal to 0, we need to factorize it. Okay, so we're going to factorize. So multiplies to negative 30 and adds to negative 1. 5 and negative 6. That's equal to 0. Now we can solve. Solving the first factor, x equals 6 would make that go to 0. And solving the next one, x equals negative 5 would make this go to 0. And we're done. Okay. Second question, we need this to equal 0, so we're going to add 3x to both sides, since that's negative 3x. And we're going to subtract 10 from both sides. That's equal to 0. So what we want is we want that to go x squared x constant every time. Now we can factorize. Factors are negative 10 that add to 3. Positive 5 minus 2. So our solutions are negative 5 and 2. Again, so 3 very similar problems. We need these factors. We need this quadratic to be equal to 0. So we're going to subtract 13x and add 6. Minus 13x plus 6 equals 0. And now I don't have a common factor in here. So what I have to do is I have to take that first term and last term and multiply them together. And I need to find the factors of 36 that'll split negative 13. So negative 9 and negative 4. So I can go 6x squared minus 9x minus 4x plus 6 equals 0. So what I've done there is I've just split that negative 13 up into 2 parts using this algorithm, if you will, or this little trick, which means I can now factorize each of these sides independently. So what can come out of 6x squared and minus 9x? A 3 and an x. So 3x comes out, leaving 2x minus 3. And I can take negative 2 out of both of these. So negative 2 comes out, leaving positive 2x and minus 3, still equal to 0. Now what I've got is 2 factors that are the same. It's just that this factor is an entire bracket, so it can actually be factorized out. So 2x minus 3 comes out, leaving 3x minus 2 equals 0. So now I can solve. First bracket would give positive 3 over 2. Second bracket would give positive 2 over 3. Awesome. Okay, what we need to do now is expand this and then subtract the 48 so that we've got it equal to 0. So we're going to have x squared minus 8x by expanding equals 48, and we're going to subtract 48 off both sides so that x squared minus 8x minus 48 is 0. And again, I'm factorising, so I need the factors of negative 48 to add to negative 8. So negative 12 and 4. So x minus 12 and x plus 4 equals 0. That's the factorisation. And my solutions are now 12 or negative 4. Okay. I should probably put these into a red box so it's really obvious what the solutions are. Alright, next 4. So pause that video, give them a go, and follow through my working. Alright, this isn't in the form that we want. We want this in ax squared plus bx plus c. So I'm going to expand this out and then make it equal 49. So I got x squared plus 6x plus 9 is 49. It's not equal to 0, so I'm going to have to subtract 49. Now it's equal to 0, and it's in that general form. I can now factorise, so factors of negative 40 to add to 6. 10, negative 4. So x plus 10, x minus 4 are my two factors. One solution is negative 10, and one solution is 4. So those are my solutions. Ooh. So the trick on that one was expand this all out, make it equal something, and just subtract that, and you're away with your factorisation. Right, we've got 5x squared minus 32x minus 12 is equal to negative 8x minus 7. So we're going to add 8x and add 7 to both sides, and that's going to make this side go to 0. So add 8x and add 7. Well, 5x squared will stay the same, but the adding 8x to negative 32 is going to take that up to negative 24x, and adding 7 to negative 12 is going to take that up to negative 5. I didn't line that up very well. Equals 0. Okay, now there's no common factor, 5, negative 24 and negative 5. So we're going to go with that trick for the complicated quadratics. First times last, negative 25. Well, factors of negative 25 that are going to split that negative 24 or add to negative 24. So negative 25 and 1. So we have 5x squared minus 25x plus 1x minus 5. So that's me splitting the negative 24. So that's still negative 24x there. It's just, I've split it into two numbers. So now I can factorise the left-hand side. A 5 and an x can come out, leaving just an x and a negative 5. We want to find the same bracket on this side. So what we can do is put that into a bracket, and there is a secret number out the front of this. That's 1. So 5x plus 1 is obviously a factor, and x minus 5 is a factor, and this is equal to 0 all the way down. One solution is negative 1 over 5. Other solution is 5. All right. We want a quadratic to equal 0. So we're going to expand both of these out. Let's just get them expanded, and then all we have to worry about is adding and subtracting to both sides. So expanding x minus 4 all squared is x squared minus 8x plus 16. And 2x plus 1 all squared, that's 4x squared plus 4x plus 1. Now I've got 4x squared on the right hand side, so I'm going to make the left hand side equal 0, because I want to keep the x squared positive. So we'll subtract x squared. We're going to add 8x, and we're going to subtract 16. Cool. So now I've got 3x squared plus 12x minus 15 equals 0, common factor of 3. What happens when I divide every single term by 3? Well, 0 divided by 3 is 0. 3x squared divided by 3 is x squared. 12x divided by 3 is 4x. And negative 15 divided by 3 is negative 5. Alright, I think I actually did this one right at the start of the video. So when we factorise this, it will go to positive 5, negative 1, and our solutions are negative 5 and 1. Alright, question 8. This side's all good. We'll just leave it as it is for now, 2x squared plus 35. But we're going to expand the right hand side, x squared plus 12x. Now I've got more x squareds on the left hand side, so I'm going to subtract x squared off both sides. So subtracting x squared is going to leave me just 1x squared, subtracting the 12x, and leaving that positive 35. Factors of positive 35 that give negative 12, negative 5, negative 7. So x minus 7, x minus 5 equals 0. Solutions are 7 and 5. Cool. Next 4. So pause the video, give these 4 a go. Now I'm going to go through them. So 2x squared minus 14x plus 12 equals 0. We have a factor of 2 in everything. So we can divide 2x squared by 2, x squared. 14x by 2 is negative 7x. And 12 by 2 is 6. And 0 divided by 2 is still 0. So you can divide everything out by that common factor. Now we want factors of positive 6 to add to negative 7. X minus 1. X minus 6. So your solutions are 1 and 6. Alright, next quadratic. 4x squared equals negative 2x plus 12. We need this to equal 0. So we're going to get everything to with the positive x squared. So we're going to add 2x and subtract 12. Cool. Now, we've actually got a common factor of 2, so we could divide everything out by 2 here. But we still now have to do the real deal, right? So we have to take that first term, multiply it by the last, because there's now no common factors. So we're looking at the number negative 12. And we want factors of negative 12, they're going to add to 1. So 4 and negative 3. So there's our split. We've split that 1 into 4 and negative 3, so that's still 1, but we'll just split it into 2 parts to make the factorisation easier. Take a 2x out of the 2x squared and 4x, leaving just x plus 2. And we can take a negative 3 out of negative 3x and negative 6, leaving positive x and positive 2. Well, x plus 2 is one factor, and a 2x minus 3 is another factor. So one solution is negative 2, and one solution is positive 3 over 2. Cool. Alright, a couple more on this page. We've got 7x squared equals negative x. So one solution is obviously 0. 7 times 0 squared is 0. And that's equal to 0. So you can kind of actually look at that and inspect it and go x is 0. The algebraic version of this though would be go 7x squared and add x, and now it's equal to 0. Now there's no constant term, so what we're going to have to do is just factorise the x out, just like we normally have done before you learned about quadratics. So taking the x out would leave 7x plus 1 in the bracket. And there we have it, x equals 0 is a solution, and x equals negative 1 over 7. And there are our 2 solutions. Right, question 12. We want x squared to be positive, so we're going to add 4x squared to both sides. Okay, it's kept the equality. We've done the same thing to both sides. It's just got rid of the negative 4x. And now we need to factorize. Again, there's no common factor. So we're going to have to use our real deal method and go 4 times 1. And we want factors of 4 that add to negative 4. So negative 2, negative 2. So we've actually got 4x squared minus 2x minus 2x plus 1 equals to 0. Factorize the left-hand side, so 2x can come out. And a negative 1 can come out of this. Alright, just be careful there. Once a negative 1 comes out of a positive 1, it's going to change the sign. Okay, but we want those brackets to be the same. Now that is a common factor. 2x minus 1 is a factor, and 2x minus 1 is a factor. What I should have noticed straight away was that this is actually a perfect square, but I didn't. So this is 2x minus 1 all squared equals 0, since it's the same bracket. And if you went down that working and you got it that way, then that's perfectly fine. But I should probably have noticed that straight away. Anyway, there's only one solution to this. X is 1 over 2. Because only one number squared can give 0, and that's 0 itself. So when 2x minus 1 equals 0, that is our solution. Okay, I think there's 3 more. 3 more to go. Yep. Let's have a look at this. So pause video, give these 3 a go. Now that you've learned a whole lot of new skills, you should be able to get these. This question 13 is a little unique. We're going to have to do something to both sides of the equation to get rid of this x in the denominator. So we're going to multiply both sides by x. That's going to give x squared on the right hand side, on the left hand side. It's going to cancel the x in the denominator on the right hand side. There we go. That was pretty easy. Now it's just like question 1. We're going to subtract 2x and subtract 3. It's now equal to 0. Now we can factorize x minus 3, x plus 1. Those two numbers multiply to negative 3 and they add to negative 2. So x equals 3 is a solution and x equals negative 1 is a solution. Question 14 is actually pretty easy. It's already equal to 0. We just have to use that method of factorization. So we're going to go first term times last term because there's no common factor. We can't cancel a 6 out of everything. And that's going to give negative 6. And we want factors of negative 6 to add to 1. So that's going to be 3 and negative 2. So we're going to go 6x squared plus 3x minus 2x minus 1 equals 0. There, I've just made 1 into positive 3 and negative 2. That makes 1. So now we can factor a 3 out and an x out of this left-hand side, leaving 2x plus 1. And we can take out a negative 1 from here. So factorize out negative 1. That's going to leave positive 2x, and it's going to leave positive 1. So we've taken out that sign changer. Alright, one bracket is 3x minus 1. And now the bracket is obviously the 2x plus 1. So one solution is 1 over 3. Positive 1 over 3. The other solution is negative 1 over 2. Cool. Alright, question 15 looks ridiculously hard. That's because you've got brackets multiplying brackets on both sides. So let's just get rid of the multiplication for now. Let's just expand everything out. So x times x squared, x times 3, 3x, 2 times x, 2x, 2 times 3 is 6. And I've still got the plus 1. That's going to be equal to, expanding this side out, 2x squared minus 4x plus x minus 2. Now let's just collect like terms on both sides. So x squared plus 5x plus 7 is equal to 2x squared minus 3x minus 2. Now I've got more x squareds on the right, so I'm going to subtract x squared off both sides. So that's going to go down to x squared. We're going to subtract 5x, so it's going to make this go to negative 8x. And we're going to subtract 7, making this go to negative 9. And now it's equal to 0. So I've subtracted these three terms off both sides. So we've done the same thing to both sides, so that's allowed. And now we want to factorise this. So factors of negative 9 that add to negative 8. So double bracket, one of them has to be positive, one has to be negative to get a negative number when you multiply. And it's going to have to be negative 9 and positive 1 to give negative 8. So x is negative 1, x is 9. There we go. 15 rearranging quadratics, all solved, hopefully, with 100% accuracy. Let me know if you find a mistake.